Like on other typical individuals, as I will begin each morning thinking about air. Is it interesting how this indestructible substance that compasses us give us oxygen and keep us alive and healthy? Have you ever wondered if this invisible gaseous substance might cause shadows? As we all know, something must be an object to have a shadows. So, can air have a shadows? Let's think.
Now, to answer our questions, let's first look at the basics. What exactly are shadows?
Basically, shadows are formed because of the direct linear propagation of light. Or simply put, light travels in straight lines. If an object like a chair, for example, blocks the path of light, the beam of light will not be able to travel around it. This causes the area directly behind the chair to appear darker. That dark area is the chair's shadow.
Now, there are three main ways an object can prevent the beam from continuing a straight path, thus casting a shadow.
The first one is absorption, where the darker objects absorb the light energy and convert it into heat. The second one is reflection, where shiny surface like mirrors reflect light, causing the rays to bounce back. In this method, the straight path of the light is broken again.
Presently, the method that we have to focus on to reply to our problem is refraction, where the object bends the beam of light as it passes from one transparent medium to another. You may have seen this when examining a pencil in a glass of water. The pencil appears to be broken even though it's not. Now, since refraction is practically breaking that straight path of light, it can enable even clear or transparent objects to cause shadows. However, for this to happen, the medium must have different indices of refraction. This means that uniform air cannot cause shadows.
We'll need the different indices of refraction for shadows to form an air. That we can either A. Heat the air, or B. Change its pressure or composition.
Let's first see what happens when we heat the air. As air heats up, it expands and its index of refraction changes. A pocket of warm air sitting next to a pocket of cold air will therefore constitute regions with different indices of refraction. The interface between the cold air and the warm air will therefore bend light and cause shadow.
Let's test a theory in a simple experiment. Let's have a light on the source on the end of the room and the heater in the middle. The ray of light will first travel to the cold air and then the warm air from the heater. This should cause a shadow of the air of the opposite wall. Wavy lines like that of the rising hot air, even the pressure variations can be caused by a plane flowing through air of gases vented into surroundings. Air can also cause similar shadows.
The ability of air variations to cause shadows are used to study the interaction of air with other objects in Schlieren photography.
So in short, yes.
Yes.
Air can cause shadows. And now you know why and how.